Alright. Colin. Jude. 2. Mathis. 7. 2, 3. Lucas. Alright, welcome back. Hope you guys had a nice break. I guess we're not doing moment of silence today, I'm not quite sure. But as I was warning you guys before the break, we had one new section to check off our list this semester before the only thing left to worry about is the semester exam. And that is going to be section 5.3, which is why we did some of the factoring for a couple days before break. We will need factoring for this section. So we have 6 class periods together and then your final exam. I believe that at some point today, probably not yet, but at some point today it should open up where you can start applying for exemptions. So you might check your student announcements for that. So we're going to spend about 4 classes on section 5.3, including a quiz, and then a couple classes on finishing up the semester exam review and giving you time to ask questions and make your note card and study like that. Usually one thing, and I can't confirm this yet, I'll have to double check before I tell you for sure, but usually with section 5.3 we count this as a 50-point major quiz. Since this doesn't have more sections to it and we don't quiz this and then quiz something else and quiz something else and then test all of it, we just do one quiz over section 5.3, but then to balance out and make sure that it is worth a good chunk of your grade, because this is important. Again, we usually make that a 50-point major assignment, so it's like a half test. So certainly something to keep in mind. Okay, so section 5.3, if you take a look at the notes and number these off as number 52. This section is all about solving equations, specifically solving trigonometric equations. So solving equations that have a cosine in them, or secant in them, or a tangent in them, something like that. Well, the good news is the first half of this lesson doesn't take too much for you to understand, because it's not much different than what you did in algebra. So questions 1, 2, 3, and 4, we'll look at how you would solve these things in algebra and then what the difference is in trig. And really there's only one extra step in trig. Okay, so if I ask you to solve this in an algebra class, hopefully the first thing you would do is undo the -1 with the +1. So same thing over here. When we're solving this trigonometric equation, we're still going to undo, add or subtract first, same first step. The next step over here would be to undo times with divide. So same thing over here, undo times with divide. Now in algebra you usually are finished because you know what x equals, and that's what you're aiming for in the question. So you get to quit. The extra step that you'll have to take with trig is we don't know what x equals, we know what cosine x equals. So to finish this, we have to use the unit circle. Now, when we do these, the directions usually either ask for it to be written like this or be written like this. In your notes, we're going to just practice both ways so that you're familiar with both ways. But on the quiz, we will only ask for one way, and in the book assignment, it only asks for one way at a time too. So the first one just says, list out all the answers between 0 and 2 pi. So we have to think about going around the unit circle and mark everywhere where cosine is positive 1/2. That would be here at pi over 3 and here at 5 pi over 3. Oops. I guess I'll stop using that color. Pi over 3, 5 pi over 3. So if the directions say list all of the solutions between 0 and 2 pi, that's what your answer should look like. But of course you guys know that you can go around the unit circle as many times as you want to. So just like pi over 3 is a spot, if you were to go one more rotation around and add 2 pi, as long as you land in that spot, cosine's still going to be 1/2. If you add 2 full rotations, you still land in the same spot, which means cosine still is 1/2. So when it says solve, this implies, you don't have to write this all the time, but this means everything. Not just the answers between 0 and 2 pi, but list out every possible answer. So what we will do is we'll say x could be pi over 3 plus any integer multiples of 2 pi. So this is like add 2 pi, add 4 pi, add 6 pi. This basically makes sure that we get all the coterminal solutions as well. And then name the other location and then include his coterminal solutions as well. So not much more work, it's just written kind of differently. So first few steps still the same, but instead of getting it down to x equals 1/2 and being able to circle our answer, we got it down to cosine x equals 1/2. We had to think about where cosine was 1/2 within one rotation of the unit circle, and then adding 2 pi, adding the coterminal responses to that. So assuming you know the unit circle and you're not rusty from the break, really the only thing that you should be getting out of this question number 1 is how it's similar to algebra skills and how you should write your answers based on the directions. So question number 2, now again, to me, I would hope that you would think this is pretty easy, but I know a lot of times this is what y'all struggle with. But from algebra, if you're solving a quadratic, you should get everything on one side set equal to 0. Just like this guy's a quadratic, you can think of this guy as a quadratic. So you would also want to get everything on one side set equal to 0. Same first step. Just like you would factor this with either guess and check or product sum or whatever else method that you know. It factors as a 2x minus 1 and an x plus 1. This is going to factor the same way. Again, this is, I briefly pointed this out to you before break, but this is why we practice the factoring. This is 2x minus 1, this would be 2 cosine x minus 1, and if this is x plus 1, this is like cosine x plus 1. The x's are now cosine x's, but otherwise it factors the same. Okay, the last thing you would do in an algebra question is set this equal to 0 and solve to get one answer, and then set this equal to 0 and solve to get the other answer, and you would get to be finished. Over here though, when we set this equal to 0 and solve, we get cosine is 1/2, and when we set this one equal to 0 and solve, we get where cosine's -1. These can't be our answers because these are not what x equals. These are what cosine x equals. But if you can solve the question on the left, either from what you've learned in Algebra 2 or through the practice that we get in this section, then you can get to this far as well. I've not done anything different. Okay, so for this part of the answer, cosine is 1/2. We already thought about this a minute ago at pi over 3 and 5 pi over 3. But also, this one has 2 places, just like this gives you 2 answers. This question gives us 2 locations for our answers. And cosine is -1 at pi. So if the directions say just give the solutions between 0 and 2 pi, There's your answers. But if it says solve, it wants us to include even the coterminal answers. So you could say pi over 3 is an answer, plus get any integer multiple of 2 pi so that you get all the coterminal solutions. Also 5 pi over 3 plus anything coterminal. Also pi plus anything coterminal. If the directions say solve, that would be fine. Now, there is one other thing I need to squeeze in here, and I would give you full credit for this on a quiz like this, because this is technically correct. But when you check your answers in the back of the book, sometimes it is going to condense this. Instead of saying all 3 of these statements, we can actually write this all in one statement. So I don't mind if you don't do this, but it's kind of needed to check your answers. So, and sometimes it's just kind of handy too. So all 3 of these, we could instead say start at pi over 3 but instead of going all the way around and adding 2 pi, I could just figure out how much I have to add to get from here to here. That would be adding 2 pi thirds. And then I notice if I add 2 pi thirds again, I get to this next location that's a solution. And then if I add 2 pi thirds again, I start hitting the same spots and start getting all the coterminal angles. So if you want to condense it into one, you can say start here, and then they're all equally spaced out by 2 pi over 3. So integer multiples of 2 pi over 3. Again, I don't care which way you write it. These 3 statements mean the same thing as this one statement. But it is easier sometimes to just do the one statement. And again, when you're checking your answers in the back of the book, and you have all 3 of these, and the back of the book only has 1 of these, you need to at least know that yours is equivalent to it. You can only do that when they're equally spaced like that. Okay, so example 2, solving a quadratic, get everything on one side set equal to 0, factor, set each factor equal to 0. Doesn't matter if it's x's or cosine x's, still the same. But within trig, you've got to think about where cosine's a half to get a couple answers. Think about where cosine's -1 to get another answer. If the directions say this, you're done. If the directions say solve, you need to say plus 2 pi n on each of those to get the coterminal angles also. Because solve implies you want everything, every answer, not just the ones between 0 and 2 pi. Okay, we've got 2 more algebra ones, and with these I tried to pick out some common errors here. So in this algebra problem, I know it's tempting to say let's divide both sides by x and we'll get x equals 1. So honestly, this might be the most common mistake that comes up in this section, so I think we need to probably write this out a little bit special. You should never divide both sides of an equation by a variable. X equals 1 is a solution to that. 1 squared is equal to 1. The problem with dividing both sides by a variable is we lost an answer. There's something else squared that's equal to itself. That would be 0. 0 squared is also equal to 0. So algebraically, don't divide both sides by x, just like I'm not going to divide both sides by cosine x. I need to, basically what I said in the last question, if it's a quadratic, put everything on one side set equal to 0. Quadratic, move everything over to one side set equal to 0. Just like the last question, we could factor. It's just that this factoring is GCF only. Set this factor equal to 0, you get a solution. Set this factor equal to 0, you get a solution. And then the only difference is with trig, we're going to have to think about where cosine is 0 and where cosine is 1. Okay, so if the directions say write out the solutions between 0 and 2 pi, I've got this spot, pi over 2, this spot, 3 pi over 2, and this spot is where cosine is 1. Now, should I call this angle 0 radians, or should I call it 2 pi, or does it matter? Okay, why does it have to be 0?
Because 0 is included.
Right, so notice this bracket means you would include 0, parentheses means you don't include 2 pi. So answer is including 0 up to 2 pi, but don't include 2 pi. 2 pi is the right location, but those directions are saying name it 0, not 2 pi. Okay, so if that's the directions, you're done. You named where cosine 0 and where cosine 1. If the directions say solve, we need to say it could be pi over 2 plus anything coterminal. It could be 3 pi over 2 plus anything coterminal. And it could be 0 plus anything coterminal. But adding 0 doesn't change anything, so I'm not going to put that. And then for these three are not equally spaced, so you could not condense these into a single statement, but you could condense it into 2 statements if you wanted to. You could leave this bottom one alone, 0 plus 2 pi n, but these red dots, they are equally spaced. To get from this one to this one, you could add pi, and to get to this one, you could add pi. So if you'd rather write both of those, you could say just start at pi over 2 and just add pi instead of adding 2 pi. This is saying the same thing as both of those because it's going halfway around each time. It's only adding pi each time instead of adding 2 pi. So again, these two on the right is how it would look in the back of the book. So main thing I need you to get out of this question, and I try to emphasize this as much as I can every year, and it is still a problem. If you divide both sides by a variable, you will lose solutions, and then your final answer can't be correct. So, okay, one more with normal algebra type of stuff, and then we'll look at some of the other trick type of questions that you need to know how to adjust to. So, if you were to solve this one, I would suspect most of you guys would undo the -1 and undo the ×2. So when our questions look like this, it's still going to be the same start. Undo the -1 and undo the ×2. Here, to go from x squared equals to just x, you want to take the square root. So you got to take the square root of both sides. Take the square root. So square root of both sides. Now, one thing I'm concerned about, and this is really important here, I know you've probably heard this hundreds of times, but people still make this mistake a lot. When you do that, when you square root both sides, you have to do plus or minus. And we have to remember how to deal with this to make this look better. I guess it's not so important in algebra. I guess in algebra you could probably get away with just circling that, but to square root a fraction is the same thing as square rooting the numerator over square rooting the denominator. And then if you wanted to rationalize in algebra, you could multiply the top by the square root of 2 and the bottom by the square root of 2. These are saying the same thing. Kind of optional in algebra, not so optional in trig, because I couldn't tell you where sine is positive or negative the square root of 1/2. I would have to say, well, square rooting a fraction is like square rooting the numerator over square rooting the denominator. That's not going to look familiar to me because it's not rationalized, but I can rationalize it. So, okay, and then on to unit circle and writing our answer in both forms, regardless of what the directions are asking. So where sine is positive square root of 2 over 2 would be in the middle of quadrants 1 and 2, and negative square root of 2 over 2 would be in the middle of quadrants 3 and 4. So if the directions just say list them out, you could say pi over 4, 3 pi over 4, and then 5 pi over 4, and 7 pi over 4. If the directions say solve, that implies all the coterminal solutions too. You could do pi over 4 plus coterminal, 3 pi over 4 plus coterminal, 5 pi over 4 plus its coterminal, and 7 pi over 4 plus its coterminal. Or, if you want to condense these, this would be one case where you would probably want to condense it, because you can see it's not hard to write that out 4 times, but it is kind of tedious. All of these are equally spaced, so I could really just list the first one, like pi over 4, and then think about what I have to add to get to here. That would be pi over 2. Notice how if you add pi over 2 again, you land here. Add pi over 2 again, you land here. Add pi over 2 again, you start getting coterminal angles. So if you just do multiples of pi over 2, this one statement is saying the same thing as these 4 statements. Again, on a quiz or a test, I'm happy with either one. Okay, so from these first 4 examples, before we move on to some of the different cases, basically it amounts to, you can solve, undo, add, subtract, solve a quadratic by getting everything on one side set equal to 0, solve with factoring, undo, add, and multiply. Remember to take the square root of both sides when you take the square root of both sides, do plus or minus, and knowing how to take the square root of a fraction is the algebra you need to remember. Then translating that to all of these trig equations, we did the exact same thing through the first half of the question. Second half of the question, we had to figure out where this happened on the unit circle, listed it out within run rotation for these directions, added plus 2 pi n for these directions, and if they're equally spaced, we can condense them. So a lot of this really depends on how well you know the unit circle and how well you can solve these algebra type questions. Okay, now not everything fits those. There's a few different question types where you have to be ready to apply a couple other little tricks here. Question 5 here, this has a typo. This is supposed to say cosine x. Okay, this does not fit questions 1 through 4 because it has different things in there. It's got sines, they're being squared, and it's got cosines. So that's almost like 2 different variables, 2 different things. But one of the things we had learned earlier this year, one of the most important things, in fact I think it's still on your desk, is the Pythagorean identities, specifically the first one. And because sine squared of any angle plus cosine squared of any angle always equals 1, we could solve this for sine squared. And so instead of saying sine squared, we could put 1 minus cosine squared. So I underlined sine squared in red, and I replaced it with what it's equal to in red. You need to understand why that's better. It's a problem when you've got sines and cosines in the same question. You want to replace one of them so it's all sines or all cosines. Now that it's all cosines, we can solve it like any of the other quadratics. We could get everything on one side set equal to 0. That's kind of already done. We could combine the 1 and the 1 to get 2. And I don't know, this is optional, but I think most people would like to multiply everything by a -1 just to make that a value be 1. And then we should be able to solve this with factoring. Now, if this intimidates you, what you can do is you can sidebar over here for a second, and everywhere there's a cosine, just replace it with an x. Get yourself to think about how this factors. And this is going to factor the same way, except that they're not x's, they're cosine x's. So instead of an x minus 2, a cosine x minus 2, and instead of an x plus 1, a cosine x plus 1. Set each factor equal to 0 and solve. And we should have answers where cosine is -1. And answers where cosine is 2. So where on the unit circle is cosine going to be 2? You guys still asleep this morning? Think about what the cosine graph looks like. It only goes up so high and down so low. We would say his range is -1 to 1. Cosine never gets higher than 1, so it could never get to 2. So I didn't do anything wrong, it's just that that part didn't give me an answer that makes sense. So answers between 0 and 2 pi, there's one place, pi. If it says solve, that means not just pi, but anything coterminal to it. So you need to add integer multiples of 2 pi to get all the coterminal solutions. But the main thing you need out of this question, and I can pause here for a second, you need to be looking to make this substitution. If you've got two different trig functions, until you make a substitution like that, it's not going to work out for you. You got to do that to get started. Okay, another question type, and this one actually came up in calculus. I don't know if it was a week before break or 2 weeks before break, but these are a little bit different because this isn't sine x equals, it's sine 2x equals. So this one does work out slightly different. So when I work these questions, I tell students, just pretend like it's an x for just a second. It's not really an x, it's really a 2x. And then start to work through the question like so. Sine is negative square root of 3 over 2 here and here. And then do these two backwards. So do the solve first. We could say one answer is 4 pi over 3 plus anything coterminal to it. And then also 5 pi over 3 plus anything coterminal to it. Now, this can't be my answer because I didn't really work the question they gave to me. I worked it like it said sine x when it's really sine 2x. So I didn't solve for x. I solved for 2x. So that's not a problem because I can simply divide everything by x here, or I'm sorry, divide everything by 2. So 2x divided by 2, 4 pi thirds divided by 2, and 2 pi n divided by 2. Same with this guy, divide everything by 2. And now I have these formulas that will give me every solution. So now I can backtrack and give the solutions between 0 and 2 pi. So if I use this guy and I let him tell me the answers, he says one of them is 2 pi over 3. 2 pi over 3 is between 0 and 2 pi, so I need to include it. But then he says if you add pi, you should get another answer. It's just 1 pi, because remember I divided everything by 2 here, so 2 pi became 1 pi. or 2 pi n became 1 pi. So if I add 1 pi to this, that would be 5 pi thirds. And then if I try to add pi to that again, that would be 8 pi thirds. But 8 pi thirds is bigger than 2 pi, so I'm done with this formula. That is a solution, but it's not a solution between 0 and 2 pi. Okay, now I need to do the same thing with this one. Use this formula to help it find all the solutions for me. So it tells me one of them is 5 pi over 6. And then it says add pi to get another one. So that would be 11 pi over 6. And then add pi to get the next one, which would be 17 pi over 6. But 17 pi over 6 is bigger than 2 pi. So it would just end up being those 4. It's pretty hard to get these 4 without first writing out these equations. That's why I suggest you do these backwards. And this is what came up in a random calculus question on a test review. Again, it was like, I guess it's been almost 3 weeks now with our break in there. But okay, let's look at one more of these. So question 7, this is either like a double angle, half angle type question. I guess this is a triple angle. But just pretend like it's a regular x for just a second. Solve it the way you normally would. We get down to where cosine is negative square root of 3 over 2. That happens in 2 locations. At 5 pi over 6 plus anything coterminal, and 7 pi over 6 plus everything coterminal. But the catch is, I rewrote this 3x to just be x for my convenience, but I'm not really done here. I don't know what x equals, I know what 3x equals. But that's still helpful because I could divide this entire equation by 3. I'm basically done with all of that now. So 3x divided by 3, 5 pi over 6 divided by 3, 2 pi thirds divided by 3. Or 2 pi divided by 3. It should be 2 pi thirds. It's supposed to be a 3. Okay, I could do the same thing over here. Divide everything by 3. And then there's the solve statements. 5 pi over 18 is an answer, plus if you add 2 pi thirds to that, you get another one. 7 pi over 18 is an answer, plus if you add 2 pi thirds to that, you get another one. Now this one's almost unreasonably difficult, so I'm going to cheat just a little bit and use my calculator here. But to backtrack and give, if it was these directions, one answer is this, 5 pi 18ths. But then also, if I add 2 pi thirds to that, which would be 17 pi 18ths. In fact, if I just write 2 pi thirds as 18ths, this would be times 6 times 6. Okay, so adding 2 pi thirds is really like adding 12 pi 18ths. I'm just getting the common denominator. If I add 12 pi 18ths again, that would be 29 pi 18ths. Is that less than 2 pi? Good. How do I know when I get to 2 pi? Okay, when your numerator is twice as big as your denominator, right? So try it again. Add 12 pi 18ths again. That would be 41 pi 18ths, but that's bigger than 2 pi. That's how I know I'm done with this top formula. But we got to get the bottom ones too. So 7 pi over 18. Add 2 pi thirds, which is the same thing as adding 12 pi 18ths. That would be 19 pi 18ths. Add it again. That would be 21 31 pi 18ths. That's still less than 2 pi, because 36 over 18 would be 2 pi. And then try to add it again, you would get 43 pi 18ths, but that's bigger than 2 pi, so that's how we know we can quit. Now that's a pretty extreme example, but it shows you there's a lot of spots. There are 6 spots that made that true. Simply by making a 3 in front of that x, it made a whole lot more solutions. You probably can't just look at your unit circle and think about what could you multiply by 3 to get a cosine of negative square root of 3 over 2. It's pretty hard to do it that way. Start with these, solve them for x by dividing everything by 3, and then know how to read these. Here's an answer, add this to get another answer, add it again to get another answer, add it again, we were outside of 2 pi. Here's an answer, add this to get another answer, add it again to get another answer, add it again, it was bigger than 2 pi. Okay, you will also see, although I feel like we solved this in a previous question, some things are just not possible. So if you divide both sides by 5, it's where sine is 5, and I know you guys have had break and you probably didn't think about trigonometry too much, but that domain and range stuff that we talked about before is not just like random trivia, it's really meant to help you. Sine can never be bigger than 1. That doesn't make sense. Cosine could never be smaller than negative 1. Both of these exist from negative 1 to 1. If you think about their graph, they only go up so high and only go down so low. So don't kill yourself trying to solve something that doesn't solve. There are some of these sprinkled in the assignment. And I think we usually throw one of these on the quiz too, which is usually an easy question, but just be ready for that. Okay, and then the last one, this one, again, just different. Doesn't work with normal approach. Would be this guy. Okay, so the first 4 we looked at, the algebra solved the way that you should have been solving algebra questions for years, even back as far as algebra 1. But then we saw if sines and cosines were mixed up, we had to plug in an identity. But we can't really do that here. This isn't a sine squared, this isn't a cosine squared, so I can't make that same substitution like we did a few questions ago. Also, this is not a 2x or a 3x. This is not the same as the last couple questions we looked at. In theory, you can do algebra here, the algebra step, and I'm not going to go through this method. I'll just let you know that it's possible. You can square both sides algebraically, and then in theory, you can work this side by FOILing this out, combining everything in the sines or combining everything in the cosines, solving it like a quadratic, get everything on one side set equal to 0, factor, set each factor equal to 0, and solve and do that. But that is not the way I would recommend doing this question. Part of the problem with this is not only does that a lot of steps and pretty challenging to not make an arithmetic mistake, but algebraically, when you square both sides of an equation like this, you may be creating extraneous solutions. Extraneous solutions are where all of your thought process and all your arithmetic and all your work is right, but the answer just doesn't solve the original equation. So you also open yourself up to that. How I would suggest you do this is just a guess and checks type of thing. There's only 4 spots on the unit circle that are exactly 1 value apart. That would be at 0. The point is 1, 0. Those are 1 apart. At pi over 2, sine and cosine are 1 apart. At pi and 3 pi over 2. Those are the only 4 times where sine and cosine are 1 different from each other. So really you only need to check these 4 spots. So remember, sine is the y values on the unit circle, and cosine is the x values on the unit circle. So if I can subtract 1 from y and it equals x, then that's the solution. So I'm just going to try them. Subtract 1 from y does not equal x. Subtract 1 from y does equal x. Subtract 1 from y, it does equal x. Subtract 1 from y would not make it equal x. Those are the two times where if you took 1 away from sine, you get cosine. And if you need the answers in this format, then just put the plus 2 pi in instead. Again, when it says subtract 1 or add 1 or something like that to them, it's easier to just try the 4 spots than it is to do it algebraically. Okay, if you would, go ahead and scan through that real quick, see if there's any immediate questions, and I can switch that back over. Otherwise, go ahead and get out a blank piece of paper, number it as 53, and copy the assignment down. Just one more minute, I'm going to switch the screen back over, so if y'all don't have the assignment copied down, you'll have to get the rest later. I think it comes out to be about 22 questions. So the first couple are not even asking you to solve, they're just asking you to check. So they're basically reminding you that you can check your answers to all of these manually without a calculator, assuming you know the unit circle. So that's what the first two are like. And then the next handful of questions are solving where the algebra is pretty straightforward and the directions say solve. Then the next set of questions has a few of the harder algebra parts where we have to do some substitutions, some trig substitutions, and the directions are just between 0 and 2 pi. So the directions are going to switch on us at question 29. Changes how our answers need to look. Then there's a couple questions where it's not an x, it's a 2x or a 3x or a 1/2 x, like we looked at in the notes. And then there's one calculator question. So this will certainly be the last book assignment of the semester. And I do have the quiz date up there for 5.3. We spend, including today, 3 full class periods before we quiz on it. So it is a lot and it does require some practice, but we will spend quite a bit of time. Also, I don't know if you guys are aware of this, but the week before break was an A week, so this week is a B week. So I will not see you on Friday this week. Next week will be an A week. So
Do we have 2 weeks and then finals week?
you have 6 days in each of your classes, 2 weeks and 2 days, and then the last 3 days of week 3 are finals only. I don't have the full semester exam. You guys can go to the school website to see the calendar and see like when A days are and B days are and all that kind of stuff. And there's a box in the middle for semester exams. I put ours up here though. I didn't put the time on there yet because it's kind of limited. But ours is the 13th. I think it's 1st, 3rd, and 5th are the 13th. Okay, I would like to look at question 5 with you real quick, just to make sure that you understand the directions for it and, I don't know, the other one that's in this group, 5 and 9. Again, this is not asking you to solve this one. You should be able to solve this one. Add the square root of 3 over. Think about where tangent's positive square root of 3. I mean, of course, that's a little harder because it's tangent. But this question's not asking you to solve. It's asking you to check. So, hypothetically, pretend like you solved it. Pretend like you got this as an answer. You should be able to check to make sure that all of your unit circle work, all your algebra, all of that was right by plugging it back in. And seeing if it gives you a true statement or not. At pi over 3, tangent is square root of 3. So, pi over 3 is confirmed to be a solution. They're throwing this at you at the start of the assignment so that you can keep in mind that every one of these you solve, even without a calculator, you can physically plug it in and make sure that it works. And this had a part 2, but you're just plugging in a different angle. Tangent at 4 pi over 3 is square root of 3. So you get a true statement. So that is guaranteed to be a solution too. So both of these work. They're wanting you to show the plugging it in and verifying that it makes a true statement. Of course, if you did a question on your quiz and you plugged it in and it did not work, that is your red flag that you did something wrong. Either an algebra mistake or a unit circle mistake or naming the angle wrong, something like that. But at least you would know something was wrong. So, okay, so you can finish copying that one down and then make sure you do the same thing with number 9. And then once you get to 11, you actually will start solving those. So I'll give you a few minutes to work a few on your own, and then I will interrupt and start taking some questions. Okay. So I know 9 is like number 5, so you should be okay there. But what after that? Which ones have y'all tried that you got stuck on?
Can you do number 9?
I'll do the first part of it. So the first part is they want you to check pi over 2. So what did you do with that pi over 2?
Plug in the x.
Okay, so it needs to go in this x and this x. So you're going to get 2 times the sine of pi over 2 squared minus the sine of pi over 2 minus 1. So what is the sine of pi over 2? Pi over 2, sine is 1. So that's why those become a 1. Square this, multiply it by 2, subtract 1, subtract 1. You get 0 on the left and 0 on the right. So that confirms that pi over 2 is a real solution. Okay, and then just do the same thing for 7 pi over 6. If it works, it's a solution. If it does not work, it is not a solution. But this is what I'm wanting to see. I want to see that you're plugging it in and checking to see if it works or not. Actually, just based on these directions, I think they're all supposed to work. They kind of imply that these are solutions and they just want you to check them. But okay, what about number 11 or 13 or 15?
13.
Number 13? Okay. Now, I don't know that this is important for question 13, but especially here at first, feel free to take this stuff and over to the side, change it to x's. Instead of cosine x's, make them x's, and then ask yourself how you would solve this, because I know this is less intimidating and it helps you get started over here. If you were to solve this, I would hope that you would get all your x's on one side, like so. So this first thing I would do on question 13 is the same. Get all the cosines on the left or the right. Doesn't matter. Just like you need all the x's on one side, you need all the cosines on one side. Over here, you would undo a minus or a plus 1 with a minus 1, and then undo a times 2 with a divide 2, and you get to quit. We're going to do the same steps over here. Undo the plus 1, undo the times 2. So this is where it becomes unique. The first few steps should not be any harder than this. In fact, you can actually write it out this way if it helps you. But to finish, I need to think about where's cosine negative 1/2. Again, I know it's been a break, but if you guys learned the unit circle correctly, then it might be a little bit slower, but you should still be able to get where cosine is negative 1/2. And then I would look at the directions, because it depends. Sometimes it's going to say give the answers between 0 and 2 pi, and sometimes it's going to say solve. This one says solve, so I'm going to give this answer plus everything coterminal to it, and give this answer plus everything coterminal to it. These are not equidistant, they're not equally spaced, so we can't combine that into a single statement. You have to have 2 statements there. Now, to pull this back to questions 5 and 9, if you had this on your quiz and then you had time, you could quickly check. Does 2 pi over 3 actually work? Not just looking at your work and hoping that you don't make the same mistake. Actually plugging it in. At 2 pi over 3, cosine is negative 1/2. So this gives positive 1/2 on the right, positive 1/2 on the left. So 2 pi over 3 works. It doesn't take very long to plug it in and check. And of course, if that's not the point of the question, you can even just do that in your head. If I plug in 4 pi over 3 here, cosine's negative 1/2, add 1, that's positive 1/2. Over here, negative 1/2 would be positive 1/2. I can check both of those pretty easily. Of course, it doesn't guarantee that you didn't miss something else, but it does guarantee that those are supposed to be part of your answer. Okay, anything more specific about 13? Okay, maybe one more question, and then I'll get out of your way again. Anyone tried 11 and need help, or 15? 11 or 15 would be good ones. Yep. 15? Okay. So, 3 times secant squared of some angle, take away 4, is supposed to be 0. And we want to know what values make that true, and not just what values, but what are all the values. Now again, totally optional, but you might want to do this at the start of the assignment. Just change all the trig functions into x's. Instead of saying secant x, just call it x. Ask yourself how you would solve this, or what would be the first couple steps. That's going to be the same first couple steps over here. Undo a -4 and undo a ×3. Then you can ask yourself, what's the next step over here? Would be take the square root of both sides, and just like in your notes, I highlighted this because this is a big deal, and this is where you're going to lose half your answers. When you take the square root of both sides, if you don't remember the plus or minus, your answer is probably going to look different than the back of the book. I know you guys have heard that hundreds of times, and you're going to hear it 100 more in this section from me, but it's still a lot of easy points lost on our quiz because of that. In fact, if I was you, I'd write that at the top of my page and make sure that I looked at it before the quiz, just because I know at least a couple questions are going to have that, and if you don't do that, then you're throwing away some points. Okay, so this would be fine in algebra. X equals, I don't really care how messy this is, but in trig, this is kind of problematic. I need this to look different. So, the square root of fraction is like square rooting the numerator over square rooting the denominator. This doesn't look familiar to me, but it's also secant. So if I take the reciprocal of the left side, I can take the reciprocal of the right side. Taking the reciprocal of both sides is perfectly fine. It keeps your equation balanced. Now I've got something that looks like it's unit circle ready. Cosine is positive square root of 3 over 2 in these two spots. Negative square root of 3 over 2 in those two spots. And the directions say solve, so it wants the coterminal answers as well. So you could name this location plus 2 pi n to get the coterminal answers. Name this one 5 pi over 6 plus 2 pi n. Name this one 7 pi over 6 plus 2 pi n. And you could name this one 11 pi over 6 plus 2 pi n. And technically that is correct. And I would give you full points on that. But I suspect when you check in the back of the book, it's probably not going to have all 4 answers written there. Because these two are equally spaced. They probably combine these into one statement. So they probably just said you could do pi over 6 and then add pi to get 7 pi over 6 and then add pi to start getting coterminal ones. And you could do 5 pi over 6 to get this one. And then you could add pi to get this one and then add pi to start getting the coterminal. So this is probably how it does it in the back of the book, but the stuff on the left is equivalent to it. However, if you don't remember the plus or minus, that's going to be the biggest thing. You're going to have no idea why they don't have 2 pi in there and they only have 1 pi in. But both of these are fine. Okay, Anything more specific about number 15? Yes.
So, when it says secant of x
Uh-huh.
plus or minus square root of 4 of 3, how'd you go from that to secant of x is plus or minus 2 over 2 over square root of 3?
Right here.
Yes.
Okay, so when you square root a fraction, like the square root of 4/3, you have to know that's the same thing as square rooting the numerator over square rooting the denominator. And then I just said the square root of 4 was 2, and the square root of 3 doesn't break down, so I did that. Okay, others about 15? Okay, let me give you about 10 or 15 minutes here to try to get a few more done. If you get hard stuck on a question, just save some space and be ready to ask it when I take some more. I'll switch over to the agenda. If you didn't have time to copy the full assignment down earlier, make sure you do that now, please. Okay, just a few more minutes and I'll take some more questions. Alright, let's see if I can help with a couple more. Okay, others you've tried and the answer didn't look right or you got stuck somewhere. No. Number 19. Okay, 19 is sin x times sin x plus 1 equals 0. Okay, so this one's actually trying to help us out a little bit because normally we have to do this step and factor this out, factor out a GCF, but they already did this. So I can set this factor equal to 0 and that's going to give some solutions, and I can set this factor equal to 0 and that's going to give some more solutions. This one we need to subtract 1 from both sides. So basically anywhere where sine is 0 should be a solution. That would be those two spots. And anywhere where sine is -1, which would be that location. And then you need to pay attention to the directions because you don't have to write it both ways like we did it in the notes. You just need to write it one way or the other. So since there's 3 spots, you could do this in 3 statements. So the first place plus everything coterminal, the next spot plus everything coterminal, and then the last spot plus everything coterminal. But I know the back, this is perfectly fine. Again, there's nothing wrong with this. Still worth full credit, but you have to at least understand why they're doing it a little bit different in the back of the book. So in the back of the book, can't do anything about this bottom one. 3 pi over 2 plus everything coterminal. But these two blue dots are equidistant. I can add pi to get from here to here, and then I can add pi to get from here to here. So I can get both of these blue dots by saying the first dot, 0, and then instead of adding all the way around, just add halfway around. So adding 0 doesn't do anything. So you could, I suspect this is probably what they did in the back of the book. But they're just combining these two statements, which are plus 2 pi n, into one statement that is just 1 pi n. This one's occurring twice as often as this. So, yeah.
Do we have to put the 0 over 2 pi n?
No, I wouldn't normally. That's fine. I was just doing it to be consistent with the other ones, but yeah, adding 0 doesn't do anything, so you don't really need to write it. Okay, any follow-up to number 19 while it's still up there? Yeah. Okay, just a second. Anything else about 19? Okay, then 15. If you need help with that one, pause what you're doing and follow along with us here. Oh, we already did 15. I knew it looked familiar. That one's already been done. You can take a picture of it if you want, or you can watch the class recording later. But still, no one's asked about 11. 17 is similar to 15, but no one's asked that yet. 21, 23, any of those you've gotten to? Okay. Then try to get a few more questions finished here. You do not have to have this finished when you come to class next time. Again, this section, we'll have another worksheet or two for some more practice, but unless you feel like you did not get much done in class, all I'm going to ask you to do for homework is maybe just a couple more, just to force your brain to think about them one more time between now and Wednesday. And maybe a question or two on your semester exam review. You should have very little to do on that. So honestly, if you just did one more question a day, it would be finished easily. But but we got about 7 minutes till you're dismissed. So again, try to get a couple more done before you call quits for today. Try to do just maybe 2 more questions between now and Wednesday, but you don't have to try to finish the whole thing. I can give you more class time before it ends up being homework.